Hello everyone, welcome to Learn Overflow. In this video, we will look into another LeetCode problem that is the kth largest element in an array. Okay, let's see what the question is like. Also, it's a medium level question, not so hard, not so tough. Let's look into it further. So it says like given an integer array nums, okay, we have an array nums over here, and it says like and an integer k. That's the integer k given to us. Like we need to return the kth largest element in the array. Note that it is the kth largest element in the sorted order, okay, not the kth distinct element. Look at the example and let's understand further. Say we have a nums array like 3, 2, 1, 5, 6, 4, and the k being 2, that means the second largest element. That's what we should return. If we just look into the array, we find the 6 being the largest element we have over here, right? And the second largest, the 2 being the k, so the second largest element is like a 5, right? So that's the what we have, and thus we can see the output is actually 5. Thus we need to return the second largest element, depending on what the k is given to us. Like if k is fourth, then we can find that there's 6, there's 5, 5, there's 4, right? So there's the fourth largest element we have over here. So we can understand like there can be multiple values as well, right? So by normal intuition, the first thing that comes in mind, okay, we have an array, sort the array in proper fashion and return the particular value out here, right? So yes, that can be a solution for us. But remember, if you're sorting the array, that taking like a lot of time to sort the array, and then you are calculating the value for it. So that's another time cost for it. Like there will be higher time complexity for it. So we need to look for better solutions or better ways to find the array. Okay, like find the particular value, because like if you look carefully, the num length is actually 10 to the power 4. So when you were like sorting an array of such a big size, it will cost you a huge time. Okay, so that's what you need to remember and you need to check over here. So we need to find some better solutions for that. The next set of solutions that can happen is like we can use an priority queue. Priority queue in the sense we can use an min heap. Okay, min heap in the sense, let's store all the values. I like not using the min heap at the first. Let's use a max heap in the first instance. Okay, so if we are using a max heap, then like we added all these elements into our max heap one by one, and then like we can have like the maximum value will be our this value, and then we will remove the, and then after like k minus 1 removal, we will find the next maximum value we have at the top of it, right? So that will be our final answer. So that can be a massive approach to it. But remember, what's happening exactly? We are adding these values one by one to our maxive. It will take a log on time, kind of a login time, yeah. And then we will be like removing one by one the all the k minus 1 elements, another login time, right? And then we will find our perfect solution for that, right? So that's not the the optimal solution we can go for. The next one we can think of is like a min heap concept. What min heap is, look carefully. If we have 3, 2, 1, 5, 6, 4, then we can add we need two elements. Okay, like we need k is 2, so we need the second largest element. So what let's do, say we added 3 in our min heap and we added 2. So in that case, 2 will be at the top, like at the min heap dot top or min heap dot peak, or at the topmost element, and the 3 will be below it, right? So that's how the min heap will be formed after you insert two elements. And when we insert one, the one will be like at the it will come at the top. So I'm just drawing as it is. So one will be coming at the top, and then the min heap will have a size of 3. But look here, what we can do at here, we need only two elements. So we know that when it's a min heap, the topmost element or the peak, the root of the element of min heap, we have the smallest sized element. Now, when we have got three elements, that is the k plus 1 elements or greater than k elements, we can actually remove one because this is not the one we need over here. We are considering the largest element. So like anything the largest element greater than the smaller than these values, we can remove that. Then we got 5, and we insert say 5 at the top, right? So 5 got inserted. So 5 won't be at the top because it's a min heap. I'm sorry, 5 will be at the bottom over here, right? So we got 5 got inserted, and now see we are finding the second largest element in this particular question. So we are confirmed that 2 cannot be the at the top of the min heap. We have 2 right now, so 2 cannot be our answer in any case, right? So we can remove that element, and then we'll add 6. 6 will again be at the at the end of the min heap at the leaf nodes, and then we find that if the size is again exceeding our current case value, then we know the 3 at the top of the min heap, whatever we have, it cannot be our answer, right? So that's true. Now we got 4, so 4 will be somewhere at the top. Okay, it won't go down the line, so we got 4. So we got 4, and now we sure that when we inserted 4, this also cannot be at the top, because we need only 2 elements. So we know that it's a min heap. So 4 is the minimum value we have over here, and we are exceeding the number of value we should look for. So 4 cannot be in our min heap just because its size is exceeding, its size is exceeding, and it's at the top of the list. So the minimum element we have over here. Okay, so yes, after the whole elements, all the elements being added, we find that we are left with only a min heap of 5 and 6. Now if we just poll just take out the smallest element out of the min heap, then we find that okay, we have only 5. Let's say the simple instance, we can find out that 5 is there, and that's the second minimum value we have over here. So this is the basic idea of using a min heap, and see what happens. You are just inserting the values and immediately removing the lowest elements you have over here, right? So that's the idea you have. So thus you can see it is a bit much faster or much lesser complexity than the other two we discussed further. So in this video, I'll discuss about this particular code we have over here, and another approach is there. So another approach is there that is exactly, you can say, we have what do you call quick select. Okay, so that's a quick select approach, and this quick select approach is more using selection algorithm, it is related to the quick sorting algorithm. So this is the fastest approach, and this is this is this is a particular algorithm that is used to find the case smallest element in an unordered list. So this is the best case solution we can have over here, and it's more like the quick sort. So I want to discuss more into this solution, actually quick select solution. So you will find another video just after this video is getting uploaded, sometime after this video. That in that video I will discuss how this quick select algorithm works and what exactly we do to find a solution like this, right, in a quick select solution. So we don't have much much lesser time complexity when it comes to quick select. So that's what we will do in our next video. So in this particular video, we'll go ahead and write our min heap concept answer for this particular question. Okay, so we'll use a min heap. Okay, so this is the more or less the solution we have over here. The main idea is we use a min heap, like a priority queue, and then we added all the elements in our array in order of n, all the elements being added. That's min heap dot offer, and then you find that once we find that this particular min heap is the size greater than k, so we simply poll our min heap, we take out an element from our min heap, the smallest element we have over here. So min heap will give us the smallest element, and then after the whole loop is run, we just return our final smallest element in our min heap. So as I discussed in the whole thing, so let's submit this question and then see what the output is all about. Is it works? Yes, it works. It takes more or less 6 millisecond timeline, right? But remember, we can reduce the timeline further if you use quick select. So quick select is actually used for that purpose. But let's go ahead, and in the next video, I'll discuss about that in depth about how this quick select works and all. So that's all about this video, guys. Thank you all for watching this video. Hope to see you soon in my next video with the quick select approach. Thank you all.